ball rolling down the street? It's fascinating to watch, isn't it? The ball just keeps going and going, seemingly unstoppable. But then, it eventually comes to a stop when it hits something or loses its momentum. It's like the ball has a mind of its own, deciding when to stop.
That's Newton's first law of motion. It's called inertia. Inertia is a fundamental concept in physics that explains why objects behave the way they do. Inertia means that objects like to keep doing what they're already doing. If an object is at rest, it will stay at rest until something forces it to move. If something is still, it wants to stay still. It's almost like the object is lazy and doesn't want to change its state. And if it's moving, it wants to keep moving in the same direction and at the same speed. It's like the object is on a mission and doesn't want to be interrupted.
Think about when you're in a car and the car suddenly stops. Your body keeps moving forward even though the car has stopped. You keep moving forward, right? That's because your body wants to keep doing what it was doing, moving forward.
That's inertia too. It's the same principle at work, whether it's a ball rolling down the street or your body in a car. Luckily, seatbelts are there to stop you from hitting the dashboard. They provide the necessary force to change your state of motion safely. So, Newton's first law tells us that objects are stubborn. They resist changes to their state of motion. They like to keep doing what they're doing, whether it's staying still or moving. Understanding this helps us predict and explain the behavior of objects in our everyday lives. Newton's second law of motion is all about force and acceleration. This law states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. Force is a push or a pull, and it can cause an object to start moving, stop moving, or change direction. Acceleration, on the other hand, is a change in speed or direction. When you see a car speeding up or a runner sprinting, that's acceleration in action.
Imagine you're pushing a grocery cart. The harder you push it, the faster it goes, right? This is because you're applying more force to the cart. That's because you're applying more force. The force you exert on the cart makes it accelerate. And the more massive the cart is, the harder you have to push to make it accelerate. This is because a heavier cart has more mass. And according to Newton's second law, more force is needed to accelerate a more massive object.
Think about riding your bike. When you pedal harder, you go faster. This is because you're applying more force to the pedals. You're applying more force to the pedals, which makes the bike accelerate. The harder you pedal, the greater the force, and the faster you go. This is a perfect example of how force and acceleration are connected in our everyday lives. Newton's third law of motion is super cool. It's one of those fundamental principles that govern how everything in our universe works. It says that for every action, there is an equal and opposite reaction. This might sound simple, but it has profound implications in our daily lives and in the world of science. This means that whenever you push or pull on something, it pushes or pulls back on you with the same amount of force. Imagine trying to move a heavy piece of furniture. As you push against it, it resists with an equal force, making it challenging to move.
Have you ever jumped off a boat onto a dock? It's a perfect example of Newton's third law in action. You push down on the boat to jump up, and the boat pushes back on you, sending you towards the dock. That's an action-reaction pair. The harder you push, the more force the boat exerts back on you, propelling you further.
Rockets work the same way. This principle is crucial for space exploration. They blast hot gas out of their engines, which creates a downward force. This force is what allows rockets to overcome Earth's gravity. The gas pushes back on the rocket with an equal and opposite force, propelling it upwards. Without this reaction force, rockets wouldn't be able to leave the ground and explore the vastness of space. Section 4. Newton's laws in your car. Newton's laws of motion are everywhere, even in your car.
When your car is parked, it stays still because of inertia. Newton's first law.
When you press the gas pedal, the car accelerates because of the force from the engine. That's Newton's second law.
And when you hit the brakes, the car slows down because of the force from the brakes.
Newton's laws of motion explain how cars move. Section 5. Newton explains the world. Newton's laws of motion help us understand how things move all around us.
And these laws are always at work. To planets orbiting the sun, from baseballs flying through the air.
Sir Isaac Newton was a brilliant scientist who figured all of this out a long time ago.
His discoveries changed the way we understand the universe.
a brilliant scientist who changed the world. Section 6. Science is fun. Science is all about asking questions and exploring the world around us.
So keep asking questions, keep experimenting, and keep having fun with science.
Science is fun and exciting.